we are ingesting a number of different metrics across the service delivery ecosystem using our unsupervised machine learning in order to create baselines for each KPI or metric and the underlying dimensions. Behind the scenes is our analytic models are looking for anomalies in the baseline trends and creating is what we call signals or alerts to potential problems. In the instance that our anomaly detection engine does find a spike like this one here, as we are analyzing each of the independent dimensions that make up that spike, we can see, is it happening across one API or multiple APIs and various different dimensions, whether this helps us determine cause, symptom, and impacted population. Once everything has been baselined, our anomaly algorithms will detect individual anomalies, which we call signals. Our signals are just indicative of abnormal behavior, but don't necessarily constitute a incident. Here we're showing a delay related to a specific host. And we also see the dimensionality of that, where this host is located, what company it's serving, the connection type for this particular enriched signal. The dark blue line represents the machine learned baseline, and the histograms represent the actual metric values. That incident itself, we use our ontology model as well as our affinity in order to group or correlate multiple signals into a correlation group for further analysis to determine whether or not it should be an incident. So this is that same signal that we saw from the last screen. We've correlated it with CPU utilization on a specific network element and also packet drops on that same host. We'll notice now that since we've correlated it with packet drops, we've increased the severity or the impact to a high, and then analyze it for root cause, key symptoms, and impacted population. Now we're looking at that same correlation group that's now been declared a high severity incident. The incident has been resolved. We see the services that are impacted, as well as the signals correlated, the duration, start time, end time, our impacted population. We see that it's affecting subscribers or customers in Texas, Florida, and North Carolina. The probable root cause was the delay across that specific host, but we also correlated in packet drops, failed authentications on the VPN servers that were having the CPU issues, as well as delay that we saw as the cause is also a symptom of the problem itself. So incidents can be managed right through. So you see who owned it and took the actions, or it can be automated. We can have different collaborations to Slack, Teams, email. We send the correlated information into the collaboration channels. We can also close an incident if it's been resolved. We can take additional actions, such as opening a ticket in an incident management system like ServiceNow or Remedy. We can change the impact and the urgency to match that of your current workflows. To see the timeline of what occurred that we saw at first, the delay was introduced. That was a low severity. We notified the Slack channel. Then we saw the occurrence of port utilization issues. Once that occurred with the delay, we increased the severity to a high. Since it was a high severity, we then open a ticket. We correlated in then CPU utilization on those VPN servers, and then we prescribed an action to an orchestrator to increase the capacity of the port to reduce the utilization and reduce the delay. It required acknowledgement from a team member, or this can be automated. Once we've seen that the orchestrator completed its action, we update the ticket. Different signals have gone back to normal. We close the ticket. and that incident then is closed.